Hi guys, welcome back to another video on Rust slang tutorial series, and in today's video, which is the second video, today we are going to discuss common programming concepts in Rust slang, and these topics will be which I have listed here. So the first one we are going to discuss is variables and its mutability. Then we are going to discuss about a constant. Then we are going to talk about a variable shading, and then we are going to talk about the data types which the Rust supports, and then we are going to talk about functions. So these are the few topics which are going to discuss in today's video. So without any further ado, so let's get started with the first one. So the first topic is about variables and mutability. So now in Rust slang, to declare a variable, you can use a keyword called let and the name of the variable, and then you can assign a value. As simple as that. Now if I want to print this, what I need to do, I need to say some string, the value of x is. Now to print, you can give curly braces like this. You can give your variable name here x, or also you can give your variable name inside this. So this will print your value on the screen. Now let me show you by running this. So I'll use the cargo run command to run this project. So the value of x is 6. Sweet. So now let's say I want to change this, the value of variable x to some another variable. Let's say I want to change this to 7. Now if I print this value again, it should throw an error. Why? I'll tell you in a second. But first let's see the result. See, it says we cannot assign twice to immutable variable. So that means in Rust by default the values are immutable. Immutable meaning once you declare and assign some value to it, you cannot change them. To make a variable mutable, you have to tell Rust at the compilation time. So you have to mark your variable as mutable by using the keyword mut. So if you say let mut x equal to 6, but then it means your variable is mutable and you can change your the value of the variable in the coming lines. If I run this program again, it should be fine. The value of x is 6 and then the value of x is 7. So that is done. So we covered our first topic, variables and mutability. Now the next topic is about constants. So let me first mark this as variables and mutability. Now let's talk about constants. So there is another keyword in Rust which says const. Now you can use this keyword to declare a constant in the Rust slang. So what this means is, now the one convention to follow here in Rust, you have to create a constant with all capital letters, and if it is more than 2 words, you have to separate it using underscore. So that is the convention which generally people follow. So I'm going to do the same here. Let's say 3 hours in seconds. So this is the constant which I want to declare. Now one more thing you need to remember about constant in Rust, you need to annotate the variable type in case of constant. So I declare the one variable here, let mut x equals to 6. Now if I want, I can annotate the variable type. Let's say I want it to be i32, so which is of integer 32 bits. I can give it 64 as well. But if I don't give anything, the Rust will assume it. So what is the default type of 6 and annotate it internally. But in case of constant, you must annotate the type of the value you want to assign it to constant. So let's say for now I want it to be unsigned integer of 32 bits, and we can assign it to some constant. You can also give a constant expression like this, which I'm doing, 60 minutes into 60 seconds into 3. So I'll get the number of seconds here. Now one more thing to remember, this cannot be a dynamic value which is calculated at runtime. For example, a return value from a function, so which will be done at the runtime, you cannot use here in case of declaring constant. This has to be a constant expression which can be calculated at compile time. So that was about a constant. Now I'll quickly go ahead and print this, say value of 3 hours, and then you can simply print this. We go ahead and do cargo run. Yeah, we got the value of 3 hours in second days or 10,800 seconds. Sweet. So now let's talk about next topic, which is variable shadowing. Now what is variable shadowing? So if you have some background in any other programming language, you must be knowing about scopes of a variable. And if a scope is having a variable, let me first say shadowing. Now if I have a variable in scope, say x equal to 6, and I then again create a new variable, let x equal to 10. Now this new variable will shadow the previous variable in this scope, and this scope can be a block scope, it can be a if condition, it can be a loop, anything. It can be a new function as well. Now if I declare this variable here, so this new x is shadowing the previous value. Now if I print this value of x inside this block scope, I should get this new value here. Now one point to remember about shadowing is that you can declare a new variable of the same name with a different data type. So I can store string here as well, let's say Pinkman. So this is valid, but if you are not doing shadowing and you are assigning a string value here, let's say some string Pinkman, this will give you error. So once you declare a variable, you cannot change its data type. So this is a statically type language. So Rust is a statically type language. You cannot change the type of the variable at runtime, but in case of shadowing you can change the type. So if I run this, you should get error. See, expected integer found string. So I'll quickly change this to 7. Okay. Now if I print this value here, I should get 10. Let me run it again. You see, I got the value 10 here. So that was about shadowing. So nothing much here. Now let's go to another topic. Okay, so let's talk about for data types. So in Rust lang we have two types of for data type categories. One is called the scalar data types, another is called the compound data type. So by scalar I mean the primitive data types, so which hold a single value in memory. So it can be integer, it can be float numbers, it can be boolean, or it can be character. So 4 data types under scalar data types, which I have mentioned here as well: integer, floats, boolean, and character. Now there is something called compound data types. Compound data types are those data type categories which hold more than one values. So first is for tuple. So this is an example of for tuple, and another is an array. So in array also you can store multiple values of same data type, but in tuples you can store multiple values of for different data types. So that is one difference between tuples and arrays. Now let's see the syntax of them. Let me first say scalar data types. So let a equal to 32. Okay, so to declare an integer and use it, you can annotate its type like this. So this I means integer of type 32-bit. If you and this can go all the way to 128 for like this. And if you want to use unsigned integer, you can give u here. Now difference between unsigned and int is unsigned means it will hold only the positive values, not the negative values, and I means signed value, so it can go from negative to positive. So with unsigned you get the entire range in a positive section, but with signed numbers the whole range is divided into two parts. Half will be integer numbers and half will be negative integers and half will be used for positive integers. So if you know you are going to use only a positive number, so you can use unsigned int, or if you know it, you can have negative values as well, then you can use integer, signed integers, and for this can go from 8 to 128. So that is about integers. Similarly for float, you can say f32 and f64. So f32 is used for single precision floating point numbers, and f64 is used for or double precision floating point numbers. So we have for two types. By default, if you don't give any type and use something like this 32.80, then it will annotate the type implicitly as f34, f64. So by default, this is going to be f64 if you don't give any type, because on modern computers f64 is as fast as f32, so it doesn't really matter. So let me remove this. So now you know about integer and float data types. To declare a boolean, you can say bool var something like this, and then you can give it some boolean value, true or false. And you can use this in the inside conditionals as well, loops for condition, all those things. So we covered integer, float, boolean. Okay, now let's talk about character. So character is also simple. If you want to declare a character, you can say a variable name equal to a character in between single quotes. So strings we generally give between double quotes, but characters we generally give between single quotes. So if it is between single quotes and a single letter, then it means it's a character data type. So character is also done. Okay, so we covered the scalar data. Well, let's talk about compound data types. So let me start with tuples. So to declare a tuple, you can simply say x. So this is a tuple, and let me annotate the type. Now in tuple, you can store values of different data types. So first value can be integer, second value can be float, and third value can be again unsigned integer of 128-bit. And I can assign all of them using the tuple syntax, so which is between these brackets. First value I can give 1, float k. For float I can give 2.40 or anything. For unsigned I can say 32. So I've declared a tuple here. Now to access individual elements, so I can use the dot syntax like this. And for demonstrate, I'm going to print the values here. Okay. So to print tuple values, you have to use a syntax like this: curly brackets, colon, and question mark. I'll talk about this syntax in the future videos, but for now, just remember you have to use this syntax for printing the tuples. So I can give a value like this, x point dot, and I can give 0. So indexing start from 0. So this is at index 0. So this is at index 1, and this is at index 2. So I can say x dot 0. If I go ahead and run this, I should get the value x10 is 1, which is this value. So we talked about tuple as well. So the major difference between tuple and array is, in tuples you can store values for different data types, but in arrays you have to store all the values of same data type. So if you see this syntax here, to declare a array you need to give the data type and length, and if you include or exclude any of the values here, like, so let's say I want to exclude this for data type, it will infer the data type from the values on the right hand side of the expression. So you can include or exclude anything from this for declaration, or I can exclude this entire thing here. So then it will infer the length and the for data type from the values on the right hand side, so what it thinks it can be. So this is one of the way to declare an array. Now let's say I want to declare an array of size 100, and I want all the values to be zeros or ones. So do you think it will be possible to write all this by hand? So there is a shorthand syntax to do that. So what I can say, I can simply say this: I want an array of size 100 with all the values being 0. So this is also one thing you can do in Rust. Now to prove this, what I'm going to do, I'm going to change this 0 to 199. So it means all the values are 199 in this array of size 100. Just to prove, I'm going to print one of the values here. What I'll do is I'll simply say value of a. To access individual variable, you have to use the square bracket syntax, and here let me say a of I'll say 90. So we should get to have a value 99 here, and instead of tuple, let me say array. So let's go ahead and run this. Cannot escape using expected. Okay, so for now I'm going to keep it outside like this. Okay, I got the value of array a0 equal is 199, so which is good. So this is what we expected. And now so why I moved this value outside this, so I'll talk about the syntax in future video, so don't worry about that. For now, just understand this. So we cannot keep this value directly inside this curly braces. We have to give it as an argument to this fln macro. Okay, so array is also done. Let's talk about functions, which is the last topic for today. So in Rust, you can define functions anywhere in the file, so the order doesn't matter. So before using the function and the declaration of the function and the usage of the function, what doesn't matter, the order matter. Anyone can come before the other. So let me go ahead and define a function. So to define a function, you have to use the word fn, then the function name. So let's say I want to create a function give sum, and then inside the brackets you need to define the parameter it's going to accept. If it is accepting anything, if it is not, you can just leave it as empty and declare a function like this. So since for this is a give sum function, I am going to accept two integer argument, sorry for that. So what I'm going to say, I want to accept a variable a of type i32. So the type is important here, so you need to annotate types in a function arguments for definition, and another will be b of type i32. And so if your function is going to give a return value, so you can define it after the brackets here, or if not, you can just simply go ahead and define the body. So this is a sum function, it's going to return some value. I can say it's going to return an integer of type i32. Now to return the sum from here, I can do two things. First, I can declare a variable saying sum equal to a plus b, and then return sum. So this is for pretty standard, so what we do in all other languages. I'm going to call this function here, let me go on a different line, let result equal to give sum. I'm going to pass two values 10, 20, and then I'm going to print sum is I'm going to give result. So I should get 30 here. So let's go ahead and run this. Let's see what do we get. So I got the sum as 30 as expected. Now one special thing about Rust lang is, since Rust is an expression based language, so what it means is, so we can return an expression from functions. So instead of me storing the value in a new variable sum and for returning it, what I can do is I can implicitly tell Rust to return value from this function by just doing this. Okay, so since for this is an expression and I want to explicitly tell Rust to return this value from this function, so I'll just remove the semicolon from here and do a plus b. So in Rust, if you want to return something from a function implicitly, what you can do is you can just keep the last line as an expression. So I can do all sorts of operation here, all sorts of operation. I can print something, can say inside func fn, give some, and then the last line I can say I want to return a plus b, so I can give the last expression as a plus b. So it will return the result of this from this function. So the last line, if you don't give return value explicitly, the function will return the last expression as value. And remember, you don't need to give a semicolon here like this, so otherwise it won't return anything. So you need to exclude semicolon from the last line to explicitly tell Rust that you want to return this value from this function. So you can, if you have some experience in JavaScript, so you might be knowing in inline function or an arrow function, you can ignore the return keyword. So something similar is happening here. So if I run this, it will give the same result. You can see sum is for 30, and before this it printed inside fn give sum. So that was about functions in Rust. So yeah, so that is all for today, guys. So we covered about variables and mutability. We also talked about a constant, how to declare a constant. We also talked about the shadowing concept. We also saw what are scalar data types and what are compound data types. We also saw how to declare tuples and use them, how to declare and use arrays, and we also saw how to create functions and call them. So in the next video we are going to cover other programming concepts which are related to the control flow of a program, like if conditions, for loops, and what all loops the Rust supports, all that, and how to give conditions, how to do switch case. So all those things we are going to discuss in the next video. Along with that, we are also going to cover one concept specific to Rust lang called ownership. So those two things we are going to cover in the next video. So that is all for today. Till then, bye bye, see you in the next one.